Hello everyone, today we are going to present a PPT on the topic World Ozone Day. Let us begin our today's presentation by talking about why it is that we celebrate the Ozone Day. In 1994, the United Nations General Assembly proclaimed 16th of September as the International Day for the Preservation of the Ozone Layer. It is all thanks to the Montreal Protocol, which we will see about in further slides, that the ozone layer is healing and expected to return to pre-1980 values by mid-century. World Ozone Day, held on September 16th, celebrates this achievement. Now let us look at the theme of World Ozone Day of this year. The theme of World Ozone Day 2021 is Ozone for Life, 36 years of ozone layer protection. This shows that the collective action guided by science is the only way to resolve major global crises. This year we celebrate 36 years of the Vienna Convention, which we will see about in further slides, and 36 years of global ozone layer protection. If we count from 1994, when this day was proclaimed, we will see that 2021 we celebrate 36 years of this day. The slogan of the day, Ozone for Life, reminds us that not only is ozone crucial for life on Earth, but that we must continue to protect the ozone layer for future generations.
to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic in particular has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
I'm pretty sure that all of you know about the protective role ozone plays in the upper layers of Earth's atmosphere. But surprisingly, the same ozone, when at the ground level, acts as a deadly poison. On the basis of the role ozone plays, it has been categorized as good ozone and bad ozone. Good ozone, or the stratospheric ozone, occurs naturally in the Earth's atmosphere. It plays a protective role by absorbing the harmful UV radiations. On the contrary, bad ozone, or the ground level ozone, formed by the reaction of pollutants in presence of sunlight, is harmful. It can trigger a variety of health problems, particularly for children, the elderly, and the people of all ages who have lung diseases such as asthma.
Ozone gas can be good and bad. In the atmosphere, good ozone protects us from the sun's harmful UV rays. In industrial processes, good ozone is used as a powerful sterilizing agent. At ground level, bad ozone is created by the reaction of urban pollution and sunlight. Indoors, ozone leaks from machinery and is a danger to worker health. Breathing even small amounts of ozone can be harmful. Symptoms include coughing, shortness of breath, and aggravation of lung diseases like asthma. To protect our health, many countries have set an exposure limit of 100 ppb ozone.
Ozone hole. The term hole here seems quite confusing, but let me tell you, the word hole isn't literal. There is no place in the atmosphere which is empty of ozone. It just refers to the area where the concentrations drop below the historical threshold of 220 Dobson units. In the early 1980s, through a combination of ground-based and satellite measurements, scientists began to realize that Earth's natural sunscreen was thinning over the South Pole each spring. The thinning of the ozone layer over Antarctica came to be known as Ozone Hole. The deepest ozone hole occurred in 1994 when the concentrations fell just to 73 Dobson units on September 30th.
Antarctic ozone hole, largest ever hole in the ozone layer, finally closes. The record-breaking 2020 Antarctic ozone hole finally closed at the end of December. During the southern hemisphere spring season, August to October, the ozone hole over the Antarctic increased in size, reaching a maximum between mid-September and mid-October. They reported that ozone analysis showed the ozone hole had closed on 28 December.
Let us imagine an ice crystal formed in a polar stratospheric cloud. Reactions in polar stratospheric clouds perform two functions critical to ozone destruction. Stable reservoirs of chlorine in our atmosphere combine on the crystalline surface to release molecular chlorine. The molecules with the ability to restabilize chlorine remain stuck to the ice crystals. In the cold, dark conditions above Antarctica, ice crystals begin to settle out, removing themselves from the destructive chlorine molecules now present in the ozone layer. High above Antarctica, weeks before sunrise will even reach the South Pole, energetic photons from the sun begin to strike the molecular chlorine within the vortex and kick off the process of destroying the ozone layer. Chlorine-free radicals destroy ozone. The resulting molecules bond together, but they are weak and easily broken. Light from the rising sun is strong enough to re-release the chlorine atoms, allowing them to destroy even more ozone. and the catalytic cycle repeats itself. Each chlorine atom can destroy thousands upon thousands of ozone molecules. Chlorine, in a similar reaction with bromine, completely wipe out entire sections of the ozone layer. Throughout August, September, and October, while the vortex remains strong, chlorine completely decimates the ozone layer and the Antarctic ozone hole fully forms. Eventually, the vortex breaks apart, and molecules with the ability to stabilize free chlorine mix back in along with ozone from the mid-latitudes. The Antarctic ozone hole fills back in until next year.
What depletes the ozone layer? Ozone depletion occurs when chlorofluorocarbons, CFC, and halons gases formerly found in aerosolous spray cans and refrigerants released into the atmosphere. When chlorine and bromine atoms come into contact with ozone in atmosphere, they destroy molecules. One chlorine molecule has the potential to destroy 1 lakh ozone molecules. CFC released from the refrigerators released in atmosphere causes ozone depletion. CFC and halons cause chemical reaction and break down ozone molecules, reducing UV radiations. Negative effects can increase eye cataracts, cancers, immune deficiency disorders. UV rays also affect plant growth, reducing agriculture productivity. Attempts towards protecting the ozone layer. To halt the depletion of the ozone layer, countries around the world agreed to stop using ozone-depleting substances. This agreement was formalized the Vienna Convention in 1985 and the Montreal Protocol in 1987. In 2009, the Vienna Convention and the Montreal Protocol became the first treaties in the history of the United Nations to achieve universal ratification. Substances covered by the protocol are referred as controlled substances.
The Vienna Convention. The scientific confirmation of the depletion of the ozone layer prompted the international community to establish a mechanism for cooperation to take action to protect the ozone layer. This was formalized in the Vienna Convention for the Protection of the Ozone Layer, which was adopted and signed by 28 countries on 22nd March 1985. In September 1987, this led to the drafting of the Montreal Protocol on substances that deplete the ozone layer. Today, the Vienna Convention is still making progress. The Montreal Protocol. It regulates the production and consumption of nearly 100 man-made chemicals referred to as ozone-depleting substances, in short ODS. Adopted on 15 September 1987, the protocol is to date the only UN treaty ever that has been ratified by every country on earth, all 198 UN member states. The Montreal Protocol phases down the consumption and production of the different ODS in a stepwise manner with different timetables for developed and developing countries. Under this treaty, all parties have specific responsibilities related to the phase out of the different group of ODS. Developing and developed countries have equal but differentiated responsibilities, but most importantly, both groups of countries have binding, time-targeted and measurable commitments. The treaty evolves over time in light of new scientific, technical and economic developments, and it continues to be amended and adjusted.
Years ago, scientists discovered a huge and harmful hole in Earth's ozone layer, and the world rallied to repair our planet. Through the Montreal Protocol, governments came together and took urgent steps to control ozone-depleting substances and achieved enormous success.
The Montreal Protocol, if you look back in history, really kind of pioneered working on a really high visibility problem in a very effective way, in a way that didn't have a lot of precedent.
Behind the scenes of the Montreal Protocol, 3 panels of world experts are bringing together the latest science and research looking at life as we know it. The panels provide governments with the technical, scientific and environmental information they need to make good policy decisions that will protect our ozone layer.
For governments around the world to make sensible policy decisions, they need to be informed by good science from across the whole range of those different disciplines.
Over the past 30 years, they have worked around the clock to help us get back on track. And it's working. With CFCs and other ozone-depleting substances banned, the ozone hole is healing.
It's been fascinating to me to see how many sectors are impacted.
99% of the reported use of ozone-depleting substances has been reported to be phased out.
We've started to see the ozone layer consequently starting to recover.
We have avoided hundreds of millions of skin cancer.
The Montreal Protocol, by design, has saved the world.
But we can't stop now. We need to keep working together to protect our ozone layer and future climate for the generations to come.
The scientific assessment, together with other assessment, are still vigilant. They are looking at what has been agreed on, the science how it is being developed, the technology how it is being developed.
The story isn't done, and the story may never be done, that we always got to pay attention to the gases in our atmosphere and what they're doing to the Earth's atmosphere and the climate of the Earth.
India's contribution in combating the problem. India signed and ratified the Vienna Convention in 1991 and the Montreal Protocol in 1992. Since 1993, the UNDP has played a crucial role in the phase-out of ozone-depleting substances by the Government of India. As a result of the support, India completely phased out production and consumption of CFCs, carbon tetrachloride, and halogens, other man-made chemicals responsible for depletion of ozone layer. With this achievement, India has contributed significantly to this global environmental cause by reducing 25,000 ozone-depleting particles tons. Carbon tetrachloride, a harmful chemical, is used to clean steel. Today, many steel companies use tetrachloroethene, which is less harmful. Manufacturers of metered-dose inhalers have completely transitioned to ozone-friendly and affordable alternatives. As a next step, UNDP is supporting the Government of India in phasing out hydrochlorofluorocarbons by 2030 as a part of the country's commitment to the Montreal Protocol.
Now that we have seen all about ozone layer, let's see some ways to conserve it, because by now we know that conservation of ozone layer is of utmost importance. The first thing that we can do is avoiding the consumption of gases that are dangerous to the ozone layer, because it is due to their content or manufacturing process is that why the ozone layer is depleting. Some of the most dangerous gases are the chlorofluorocarbons, halogenated hydrocarbon, methyl bromide and nitrous oxide, and it is due to their content in the atmosphere that ozone layer is depleting. The other methods that we can try is the minimizing of uses of cars. The best transportation in urban area is bicycle or walking, and if you use a car to a destination, you should try to carpool with others to decrease the use of cars to make less pollution and save environment.